Hello guys, in this video I'm going to show you how to solve k-pairs with largest sums. So, given two sorted arrays in descending order, find k-pairs with largest sum, where each pair consists of numbers from both the arrays. Right. So how? Let's look at an example here. Right, we're given two array that is sorted by itself in descending order. So you could see 9, 8, 2, and 6, 3, 1. Right, we have two arrays. So now our goal is to find three pairs with k equal to 3. Three pairs with largest sum, where each pair consists of number from both the arrays. Right. So let's put two arrays in parallel so that you can see what are the pairs here, right? So here the two arrays have equal size, right? But it could be different. 3, 1, right? So as you can see, because the array is sorted, so the largest number is atop each array, right? So probably the largest, you can know for sure, that would be two first number from each array, which is 6, 9, and 6. Produce 15. It will be the largest sum. But what is the next one? The next one could be the largest. Let's say here's the number one, right? The largest here. But for the second largest sum, it could be the largest from first array 9 with second largest of second array, or it could be the largest of second array with second largest of. Okay. So here we have two choices, but if we go to the next one, what will be the third largest? It kind of is kind of more confusing as we if we go on here. It could be anything, like if we, like in this case it would be 14. This one would be the next largest. So probably The next one, the next one will be this one, I guess. Right. We will take this one out of here because this will produce 14, but this will produce 15. No, 12 only, right? So this will produce 12, but it is just our guess, right? This actually is not the third largest, can be not the third largest, because here, since the third one here, it could be 6, and 2 is also your option C. Let's imagine the first number can be very, very large, like let's say 100 here, right? So a number, so this will kind of dominate if you try to add it with any number, right? So even when we have a lot of smaller number here, if we add with this number, it will always beat other choice as well. So if we go with this approach, it's kind of not very, it will be very hard to reason about. So let's say here we're finding k pairs, right? K pair with largest sum. So for this kind of problem, we can think of a heap, right? Because a heap, with a heap, we always have access to the largest, right? Very important features of heap is that we always have access to the largest number of the heap, right? So the idea here is just is that we have one of the most intuitive ways just to brute force all the possibility here, right? So we just keep adding the all the pairs of all the pairs of from 2 arrays into our heap, right? So we try to maintain the heap size at k, so that the heap always store the top largest, right? Top k largest. So that would be an approach here, I guess. So just let's try to I think we can start with this and see how we can improve upon that. So in order to like check all the pairs from 2 arrays, when I use a nested for loop here, I guess. First, from the outside for loop, from the outer for loop, I will loop through all the numbers in the first list. So I equal to 0, I less than psi, I plus plus. Okay. Okay. So for each number here, when I look through all numbers in the second list to produce a pair, right? So the second loop, j is equal to 0, j less than L2 length, j plus plus. Okay, so the pair that inside here, we have a pair of L1 at index I and L2 at index j. So with this nexus for loop, we will be able to check all the pairs from these two, right? So here we need because here we need k largest, right? So I'm gonna use a min heap so that we always have access to the smallest one in the heap now. So if the current sum is greater than the smallest in the heap, I will pop out the smallest, right? And add the current to the heap so that our heap always maintain the top largest currently, right? Current top largest. Okay, so it would be a min heap here. As you can see, here we need to return all the pairs, right? So I will initialize a pair first in a list, and our min heap here. Here I will use a heap class. Initialize is empty. The third argument will determine whether it is a min heap or max heap. So it's a min heap, so it would be b minus a. But actually, we will need to determine the data structures that we add to the heap, right? So we don't want to just add the sum itself, because as we take because the final, we want to know not only the sum but what are the numbers that that produce that sum, right? So we need to store the numbers. So my initial idea is here is to keep the item that is added to the min heap would be an array with the first index would be the first number, the first num. Second index will be second num, and third index will be the sum of the first num and second num. Right, so here we will compare this sum, which is second index, which is index 2, right? Min heap. Okay, so here I will add min heap and add it into here. L1 index I, first number, second number will be L2 at index J, and last would be the sum of 2 plus L2 at index J here. So here, here we don't want to just keep adding item into the min heap, right? We need to pop it out also to maintain the size k, right? So we want to just keep adding as long as uh, the size of the min heap of length is less than k, right? Here, but when the size reaches k, at that time we only want to add new item into new pair of numbers, right? Uh, into the min heap if those pairs produce better sum, larger sum than the uh, smallest in the min heap. So here I could extract this out into sum because we will need it inside here. So if our sum is uh, better than uh, the smallest in the min heap, which is can be accepted by pick. Okay, this will be the item. I will access the sum by index 2. If this is the case, then I will pop one now from the min heap and add the new one, which is the current the current pairs, which is it will be the same, I guess. Okay. Uh, so with this, our min heap will always maintain at the end, right? At the end, it will maintain k largest item, k pairs with largest sum. So here we just I've just deleted this pairs because we don't need it. We can just extract the pairs from the min heap directly. So it would be min heap. I can use map here. So item which item I will map it into item here. I can destructure out into first num and second num, and here I will return first num and second num. Okay, let's run a test. Just 5, no 14, 5. Oops. What is that? Mini in other functions. My mistake. Need to add it to the. We need to add item of an array. Okay, it works. But the questions might come to you that do we really need uh, to check all the pairs? We could lead to n square time complexity. Uh, let's see how we can improve this. Okay, let's say we have more number here. 6y. Oh, okay. We have 22, 13, 9. One example, right? So if the KE3, let's say the KE3, do we really need to probably the K largest, because we 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 aren't using a given piece of information from the problem statement, which is two arrays are sorted in descending order by itself, right? By themselves. So this one is sorted, and this one is sorted in ascending order, descending order. So probably with k equal to 3, which means we need to find 3 pairs, right? So then the 3 pairs we can be will be for sure. We can be sure that 3 pairs will be at can be 3 pairs must be formed from first 3 of the first array and first 3 of the second array. That'll be for sure, right? Why is that? Because our array is sorted, right? So if, like for example, if we take one number from, like for example, we take 6, right? And we plus with 100 here, where I intentionally take 6 here, that is outside of the first 3, right? I will demonstrate that the largest sum will be within this sign, but not outside. So if we take 6 here with plus 100, then it will be for sure less than 100 plus 7, right? So it must be inside this range. That will be an improvement that we can make here. So here I don't want to go all the way to the end of the L1, but we could make an improvement here, which is I will take the mean of k and L1.length. So if psi of L1 is greater than k, we only want to uh, iterate through the first k, and same for the inner loop. Okay, here will be L2. Okay, that should be work too. That will be an improvement we can make here. So this would reduce it into k square. It will be k square. Is there anything that we can improve from here? Let's look at here. Probably we're gonna start. For example, here 9. We check here. We, for example, with this loop, this D2 loop, we start 9 here. We then go to inner loop, start a second. So we 100 here. We first form 900 is the first pair, right? And the next one here, the next one here. Now we have um, three pairs inside our heap, right? So now from this point we will run into this case instead. So from this point we only add new pairs if it beat the smallest inside the heap. So from this point, okay, so we start For example, here, okay, we run out of three here, three pairs. Now we start the next one from the first list, which is 8. Again, now 8 will, with 100 will form the next pair, right? But what if this pair couldn't beat, what if this pair couldn't beat the smallest, the smallest, the sum with smallest pair in the heap? It means that any next pairs, any next pair of 8 with next number uh, from second array here, you also cannot beat uh, the smallest in the heap. Why that? Because the arrays is sorted in a descending order by cell. So if 8 plus 100 cannot beat, then any next pairs that include 8 you also cannot beat, right? So it would be this um, it would be the case of the L here, right? If the sum is less than or equal to the smallest, and in that case we probably we can exit early with this inner loop, right? That with this inner loop that has 8 is a that has 8 at the first number, right? For example, right? So if this inside loop that we run into this case, we can break early here, and we just can run into the next I here, which is in this case 7. Again, we fix 7 here, start from 100 again. Uh, Again, we start comparing this pair with smallest one in the heap, right? It could larger than the smallest in the heap, which is this case, or it could less than, right? It will be this guy. Again, if it less than, then we can exit early from this inner loop, right? Because uh, any further pairs uh, we also cannot beat um, the smallest in the min heap, because we have this important features, which is the arrays are sorted in descending order, right? So another improvement that we can make here, right? Okay, it still works. So that is it for this problem. Thanks for watching. See you in the next video.